Now, why did we discuss all of this so much, right? The key point is it is okay to pass more arguments to a function as long as the stack cleanup happens in the caller. Okay. Now, this is a very significant thing, okay, because of the following reason, right? So, all that we discussed till now is not some hypothetical or a pathological case that we are never going to encounter in C programming. In fact, it is the same fundamentals that we discussed is exploited heavily by one of the most widely used functions in C programming, and that is the famous printf function. Okay, what is the signature of this function? Char star dot dot dot. Okay, if you look at the function declaration, it will be like this. Okay, some integer, right? Int printf char star of this, right? What does this basically say? It means that the printf function expects at least one char star, one string that needs to be passed to it, right? Beyond this, you can choose to pass any number of other arguments, and it turns out that depending on the person D's and the person C's that are sitting inside that string, you need to pass appropriate integers that match it, or characters or strings or whatever, right? So for example, I could have the following, right? So let me start with this main, and I will say printf, right, hello. Okay, then I will say printf %d comma 2. I will say printf %d 2% is 2 comma 4. Finally, %d 2 comma 4 comma 6. Okay. Now, so what you see is basically it's the same function printf that is being called, but you are passing different number of arguments to it. Now, most importantly, what you see is at least one char star. The first argument is a char star pointer. Okay, so the way this will happen is in your C code, right? For example, if I come here, right, and I look at this, you just see what happens here. Okay, so I have a printf here, right, and I am passing some string to it. You see that that string itself is defined here like this, right, and that has an address. Okay, so therefore, when you do this printf and all that, your this offset sg, you see this push, so you are actually going to use that as an address to send that string across. So that's a string, and you have a pointer to that string. You are going to use that address and send it to printf for it to process. So the key point is that printf expects at least one char star pointer, and that we are giving in every case, right? That's why we said it's not okay to, so for example, I cannot call printf just like this. That is illegal, and even if the compiler does by chance allow it to go through, if you execute, you will land up in trouble. You will have parameter mismatch, maybe not parameter mismatch, but you will have illegal, you will land up in a different location, right? And you will also end up accessing the stack of the calling function incorrectly. Okay, but on the other hand, if you pass at least one char star, right, then what will happen? Let's assume that this string is sitting somewhere in memory. These strings are sitting in memory. So what you will do is you will push some offset address of the string. Okay, and then you will call printf. Okay, now in this case, what will you do? You will first push 2. You are pushing the parameter, then you are going to exactly do this call. Okay. Yeah. Right. Now, if I want to worry about this guy, what will happen? You will do push 4 and then exactly this thing will get, right, and of course you have to do a push 2 in between, right, and the last call will get translated to pushing 6, 4, 2, then the char star offset address and then calling printf. So what will happen is when you return from printf, you will do add esp comma 4. Why? Because you have passed only one char star, one pointer. That means you have pushed one pointer onto this thing, and therefore you will have to undo that push. Here you will do add esp comma what? You have pushed one char star pointer and one integer 8. So this one will be add esp comma this will be add esp comma 12, right, and likewise the last call will be add esp comma 16. Why? So the point is that when the function is being invoked, you know exactly how many parameters were passed, and therefore that function knows how much to clean up the stack by, right, and that's precisely why a fantastic function like printf works so beautifully. Okay, if you look at the function printf itself, right, inside it will only do the ret, it will not do ret any n, because it's a cdecl call. It has to be a variable argument list function type, and therefore it's a cdecl call. It will do ret. Stack cleanup happens outside that function in the calling function. So this now leads us to a very interesting point that we had just assumed very casually up to this point. We just said, okay, let's assume that all function parameters are pushed right to left. Okay. Now, why did we choose this? Is this hard and fast? Is it just a convention, or is it mandatory that we actually go right to left? What happens if I push my parameters left to right? Okay. So for example, if I have function call which is 2, 4, right? We just said you will do push 4, push 2 and then call fn, right? But can't I do it the other way? Push 2, push 4, call fn, right? This is what we are going to look at, and we are going to see if any one direction is preferred or it is mandatory to actually do it in only one way, right? So what we will do now is we are going to look at the idea of parameter pushing, right? And we are going to see the order in which this has to be done, right? So let's take the best function again to handle such cases. It's the printf function. The function, as I told you, takes at least one char star string. So if you just have a printf hello world, you will do push the address of the string and then call printf. Now you can pass more arguments to it, right? You do hello world, date is so and so something, right? And you get a whole thing. So what do you do in this hello world followed by 3 integers? You will end up pushing 4 arguments, because the first one is a char star pointer to that string. Then you will do the 3% d's, corresponding to the 3% d's, you will pass some more integers and then call printf. Okay. So what we are going to do is, we will assume for now that we are pushing the parameters left to right. Okay. That means we are just going to do the opposite of what we have been doing till now, but hypothetically. Okay. It doesn't happen like this really in this thing. So what will happen is, so basically you have the, I am showing you the stack here. Okay. So what will you do? You are going to call, you are going to push the address string. So that is what is sitting at this location here, right? So if you look at maybe I'll draw one example here and then we can look at that thing. So what we are saying is, if I say printf of hello, right, then this is going to translate to push some address, right, and then you are going to call printf, right, and then you are going to return after this point to this add esp, comma 4, okay. So you are going to return to this guy, and therefore whatever this is your return address, RET address, okay. So the stack is going to look like this, right. The stack is, so you push first the address str, right, and then you come to this call printf, the return address is sitting here, right, this is my return address, right, and then what do? The EBP of main will get pushed onto stack, right. You are now going to get into that printf function, and the first instruction in the printf will be the prologue, which is push EBP. So EBP of main will sit here, okay. So that is what you are seeing in this. So the stack is basically this, you know, this is the address string, then return address and EBP of main. This is how it is going to look, okay. Now since it's only one parameter, it doesn't matter left to right or right to left. Now let us see the case of pushing two parameters. So I am going to do hello %d, that is a char star string and one integer. So I'll do push address string, then I will do push 0x002 and then call printf. Okay, remember again I am going left to right now, and therefore the first thing I will push is the address of string, and then I will call printf. So now the stack is going to look like this when you enter and execute the push EBP of printf, right. It's going to the EBP of main, then the return address as I showed you, then 0x002, the parameter that was here, right, and then the address string, okay. Now let us say I do 3 parameters, okay, one char star, 2 integers. Then I do push addr string, you do push 0x002, push 0x003 and then call printf. What is going to happen when you come into the printf function? The first instruction is push EBP. Remember, after you execute that, EBP of main gets pushed onto the stack, and then below that you see all this. Below means actually in the next higher addresses, RET underscore ADDR, the 3, 2 and then ADDR string, right. Now how is this printf going to operate? If you look at the idea of printf, right, what are you going to do? You are basically going to read that first char star, char star string, right, and then understand what is in that, whether there is a %d, %f, %c and all that. Based on that you are going to interpret what is coming later, okay. So therefore if you look at the compilation of the printf function itself, right, the printf function itself is, you have char star pstr pointer and then dot dot dot, right. Inside this you are going to read this contents of pstr, the string, and interpret, okay, if it's %d you do this, if it's %s you do this and so on. Therefore where is this pstr? What is this pstr? Where is this going to sit? It's going to sit, it is expected to sit in EBP plus 8. Why? Because that is the first parameter that is going to be passed to this function. It has to be at EBP plus 8. Now when you push parameters, right, from left to right, what is happening? Of course, the address of string, this is EBP plus 8. Okay. Why? Because my EBP is pointing, my EBP is pointing at this location, right? So, EBP plus 4 and then EBP plus 8, this is what it is. So, EBP plus 8 is exactly where the address string is when you pass only one parameter. But the moment you pass two parameters, okay, my EBP will sit here, and this guy is EBP plus 12. Here EBP plus what? 1, 2, 3, 4, 16, right? So, depending on the number of parameters that you are calling printf with, my address, the string address where all this %d, %f information is actually moving further and further away, and therefore there is no way for me to compile printf assuming that it can even access the string. Remember, I told you that the compilation process is you look at printf and you should be able to compile it to the equivalent assembly code irrespective of how it is called from any other location. So, it does not know whether it will be called with 2 parameters, 3 parameters, 4 parameters, but it needs this char star string to be accessed in order to understand what the next parameters are, and therefore it has to be at a fixed location at EBP plus 8, the first parameter, okay, and that is why you need to push parameters compulsorily from right to left. So, in this case, I will now show you the stack picture again, where you do only one string. Here it does not matter. This is my EBP, this is EBP plus 8, right. Now, what do? I do hello %d 2, right. Now, I push 2, then addr string and then call printf. Now, what is going to happen? My EBP will be here and this is EBP plus 8. Finally, when I do two integers and one char star, when I do push 3, push 2 and then the addr string. Again here my EBP is here and this is EBP plus 8. Therefore, in all 3 locations, my addr string, that string, the first parameter and the mandatory parameter always sat in EBP plus 8, okay, and that is why you need to push parameters from right to left and not left to right, okay. So, this is the biggest advantage, especially in order to handle variable argument list functions like printf, right. Now, if you didn't have this option at all, then it didn't matter. You could actually have right to left or left to right, because the function definition expects certain parameters. You are always going to call it only with those parameters, right. There is a perfect match there, in which case the compiler can actually map it appropriately without any issue, right. So, therefore, in summary, you have to necessarily push parameters right to left so that functions like printf can be implemented, and functions like printf are mandatory for us to actually handle such sophisticated printing statements in C.